Today is May 1, 2020, and we continue with our online series. Today we are going to be going over skill K9, which is congruence in equilateral and isosceles triangles. So when you get done with this, you should be able to determine congruence between two isosceles triangles or two equilateral triangles. So a lot of times people confuse these two. Equilateral triangles are a type of isosceles triangle in that both triangles have two congruent sides, but an equilateral triangle also has a third congruent side. So a lot of people will say to me, well, shoot, Mr. Warren, equilateral triangles have three congruent sides, not two, so they can't be a type of isosceles triangle. But turn it around and think about it this way. And here I'm going to show you an example. These are two triangles that have two congruent sides. So triangle ABC, AB is congruent to BC. Triangle DEF, DE is congruent to EF. And so these are both considered isosceles triangles. And as a result of the characteristics of the relationships between the angles and the sides, the angles that are at the base of the two sides that are congruent are also congruent. So again, over here with triangle DEF, again you have two congruent sides, and the two base triangles D and F are congruent. So in this way, they're exactly the same. The only difference is with this triangle DEF at the bottom, the third side is also congruent to the other two. But we aren't going to get into that issue here. We're just comparing the similarities between these two. So again, they're both isosceles triangles. But this one is an equilateral isosceles triangle. So if you can just think of it that way, then you're going to understand it a little bit better. Okay, so let's go back over and take a look at some of the other rules here. So the basic rule is that isosceles triangles have two sides of the triangle that are congruent if and only if the angles opposite their sides are congruent. So we were just looking at the base angles are congruent if the two adjacent sides are congruent. And the sides marked with the same number of tick marks are congruent. So going back to our picture here, you'll notice that AB has one tick mark, BC has one tick mark. So those two sides are congruent, and the two angles have one arc, so they're congruent. And over here, DF, DE has two tick marks, EF has two tick marks, so those sides are congruent. And base angle D and base angle F have two arcs, so those two angles are congruent. All right. So let's move on. Okay, so we're going to look at our first example, and the question here is, what is the value of x? So x is a angle measurement. So I'll put a little degree mark there. What is the value of x in triangle CDE below? So let's just go through the scenario as to how these things work. I'm going to put these together because it'll be easier to flip the pages. So, what do you notice about the triangle? You notice that, yes, you have one angle that is unknown, so we call that x. And then we have another angle that is, and that's angle E is 88 degrees, and angle C here is 46 degrees. So CE and DE, the sides, CE and DE, have each a tick mark with one tick each. So we know that CE is congruent to DE. Now, by the isosceles triangle theorem, the angles opposite CE, line segment CE and line segment DE must also be congruent. So I've got a picture of it again down here. And the angle opposite CE is angle D. So CE, here's CE, and so the side opposite is angle D, okay? And the angles opposite of DE is angle C. So angle D and angle C have the same measure. Well, that's not quite correct. So angle D and angle C have the measures shown here, not the same measure. So forgive me for that. So have the measures shown. And of course, the angles DE and CE do have the same measure. For that reason, the opposite angles, angle D and angle C, are congruent. So they have the same measure, okay? So from the diagram U, and I dropped the Y, I can see that the measure of angle C is 46 degrees and the measure of angle D is X, but it's got to equal that 46 degrees. Now, if nothing else, if you aren't sure, you got to remember that the sum of the interior angles of a triangle always equal 180 degrees. So that would mean that 180 degrees equals 46 degrees, okay, plus 88 degrees plus X. So all we do is we combine like terms. So 88 and 46 using our calculator makes it easier if we do that. So 88, let's turn it on, 88 plus 46. You add those up and you get 134 degrees. So 180 degrees equals 134 degrees plus X. Now you want to get X by itself, you subtract 134 from both sides. So I'm subtracting 134 degrees from 180. So I'll take 180 minus 134, and the answer that I get for that is 46 degrees. So this cancels, this is 46 degrees, and that's what X equals. And that, when you see that, 46 degrees over here, you realize now that angle D and angle C are indeed congruent, and they should be under the rule here about isosceles triangles. All right? So that's how this works. It's pretty simple to do. I've got one more here just to make sure that we know what we're doing. So what is the value of T? T is a variable in GHI below, triangle GHI. So again, by the isosceles triangle theorem, GH and HI, those line segments are congruent, and therefore angle T up here, and notice the tick marks, angle T up here has to also be congruent to angle G, because those are the two base angles that are associated with the two sides. So we know that T plus whatever this is over here and 84 have to equal 180 degrees. Now, we're looking at this and we say, well, wait, we got one unknown here, and we now have two unknowns. How can we solve this when we have two unknowns? Well, yeah, but aren't those unknowns the same value? Yes, they are. So this is 1t, and this is another 1t. So we know here that 180 degrees then equals 1t plus 1t plus the h, angle h, 84 degrees. So this t plus t is 2t, so 180 degrees equals 2t plus 84 degrees. Subtract 84 from both sides. use your calculator again to subtract 84 from 180. So let's clear this. Okay, so 180 minus 84, and we get 96, it looks like. Okay, so that means then that 180 minus 84 is 96 degrees, and that equals 2t. Now we divide by 2 because we're undoing to find out what t is all by itself. 2 over 2 is 1t, so 96 divided by 2, so we already have 96 up here. We divide that by 2, and we find out that 1t is 48. So 48 equals t. Okay? So now we know that that's what it is, 48 degrees. All right, so I've given you 2 examples, and recognize that as you move through these, you're going to find that we're going to switch from using just 2 numbers and maybe a single variable to a more complex variable situation. We may also use algebra here for the 2 sides, so that can happen too. And just if that happens, just remember that the 2 sides equal each other. So use those principles that you've been using before for these, and you should have no trouble with them. Okay, so that's pretty much it. Have a wonderful afternoon. We're starting next week with the 4th in these. This is the 3rd in the 5 for the next test, and the next test is going to be next Friday. So we've done now 3. Tomorrow I will get out the 4th one, and then we've got a 5th one to finish, and then we're done. Okay, done with this particular group, the 2nd group. You can do the 2nd test, and you'll get a little bit better idea of where your score is going. Okay, and remember, if you have any questions, don't hesitate to contact me. If you need to get on to a Zoom meeting with me, maybe exchange screens, we can do that. No issues at all. Look forward to seeing you, and have a great afternoon. Thank you. Bye-bye now.